Hello students, welcome back to Chemical Kinetics. In this module, we are going to see the factors which affect rate of reaction. Many of these factors that affect the rate of reaction can be identified very easily by you guys. So let us try and see one by one which are the factors which affect rate of reaction. First of all, you've got concentration or pressure. Remember that concentration is for solutions and pressure is for gases. The second factor which affects the rate of reaction will be temperature. This temperature affects the rate of reaction. Along with temperature, you have nature of reactants. This point will be discussed as we go ahead much more in depth. You also have presence of light and presence of catalyst which affect the rate of reaction. But before we understand how each of these factors affects rate of reaction, let's try and understand the requirements for a reaction to occur very well. If I ask you to carry out a chemical reaction, what are the conditions under which this reaction will occur very well, very fast? Number one, the molecules should collide. Of course, they have to collide very well. Without collision between molecules, the reaction cannot go ahead. Second point would be they should collide with sufficient energy. So now when you've got molecules colliding among themselves, they should collide with sufficient energy that will again facilitate the rate of reaction. Now how this collision, the energy of collision will affect your rate will be understood later in a module called as collision theory. But right now you can safely take my word for it. So these are the two factors which have an effect on the factors which affect rate of reactions. If you remember, these were the factors: concentration or pressure, temperature, nature of reactants, light, and presence of a catalyst. Let us see how concentration or pressure affects the rate of chemical reactions. Let's consider a chemical reaction. This one right here, zinc plus HCl giving you zinc chloride with evolution of hydrogen gas. Let's say we were to carry out this reaction in two different test tubes. Here we've got two test tubes, and inside these test tubes we've got zinc. Now first test tube is filled with dilute HCl for the reaction to happen, and the second one is filled with concentrated HCl. Now the reaction will very well take place in the one with dilute HCl, but look what happens in the one with concentrated HCl. Naturally the reaction becomes more vigorous. So I can say that the rate of reaction is directly proportional to the concentration of reactants. If the reactants are more concentrated, the rate will be more. If the reactants are less concentrated, that means they are dilute, then the reaction will be slow. And the reason for that is fairly simple. I mean, if you've got a higher concentration of reactants, it will lead to higher chances of collision. And as we have just seen, more collisions corresponds to a greater rate of reaction. Also, if you talk about pressure for gases, now I've got two vessels over here. One of them is at lower pressure and the other one is at a higher pressure. Naturally, the one which is at a higher pressure has more chances of collisions inside it, which means that pressure for gases is also directly proportional to the rate of reaction. That is what happens with concentration and pressure. They are both directly proportional to the rate of reaction. Now, if you remember, students, these were the factors which affect rate of reaction, out of which temperature is the second factor. This one is fairly easy. If you remember, the molecules should collide with sufficient energy, which can be increased with temperature. So when I take this factor into consideration, say there is a reaction which is taking place and it is taking place at a high temperature. At high temperature, the molecules have more kinetic energy, and more kinetic energy will correspond to more violent collisions. These violent collisions happen with such great energy that the reaction rate increases. So more violent collisions are successful at high temperature as compared to low temperature. So I can say that as the temperature is increased, the rate of reaction also increases due to excessive kinetic energy. In fact, if you want to know, the reaction rate almost becomes double for every 10 degrees Celsius rise in the temperature. Which means that if I increase the temperature of the reaction mixture from 20 degrees Celsius to 30 degrees Celsius, the reaction rate will almost double. That is what happens when temperature is increased. So here we have seen two factors which affect rate of reaction: concentration or pressure for gases and temperature. For the remaining factors, let's move on to the next module. Till then, thank you.